صور صورنا صورنا. Okay, because maybe some more of you have the question how to compile the program that you now finished. I will explain how to do this. So what you should not do is in your Genie program, simply click on compile file, because it will tell you that it can't include the first header file and that the compilation failed. So what you need to do is you need to compile not only this element file, but you need to compile FEEP. And therefore, you need to save this element file in the correct folder in your Z drive. So when you go to Z drive, you have a folder named Linux Profile, and there you have a folder named FEEP PV, and there you have a folder named Elements. And there you should save your file element03. You will see that there is already a file named element03. This is only a dummy file, so you can simply overwrite this dummy element03 file with the one that you are working on right now, and then your file is saved in basically when you compile FEEP, it can access the correct file. If you have done this, what you do next is maybe I will just open a new terminal. What you do then to compile FEEP is in your terminal. You can open it in a position in a folder where you have an input file, but you can also just open this terminal anywhere, and then you type FEEP PV, and then if you start it for the first time, it will take some time to compile, and then after a while, it will either say compilation succeeded, or it will show you a big arrow, and this arrow is pointing upwards, and then above this arrow you see a note on the errors in your code. Okay, so when you are finished with your programming, save your element03 file in the correct folder, Linux Profile, FEEP PV, and then the Elements folder, overwrite the dummy file there, and then open a terminal and type in FEEP PV to compile. This is very important. This you need to do now, from now on until the rest of the semester. I assume that most of you are also attending the nonlinear finite element method class. So this will be similar in those two courses. So you should know where to use this, or how to use this, and where to put your files. Is this clear to everyone? Okay, Rajesh, could you still hear what I was saying, or could you not hear what I was saying? Okay, you couldn't hear. All right, I will tell you once more. You need to save your file element03 in a specific folder. Click on Z drive, then go to Linux Profile, and there you should have a folder FEEP PV, and there you should have a folder Elements. And here you have some files already, and you have that file element03.f already. The file that is in this folder already is a dummy file. You can simply overwrite this dummy file with your new element03 file. So save the file here, and then what you do is you open a terminal anywhere and you simply type in FEEP PV and hit enter. And then it takes some time to compile, and either it says compilation succeeded, which usually doesn't happen when you start programming, because everyone makes mistakes while programming. So if your program is correct, if the compilation goes correct, then it says compilation succeeded. If not, then you will see a big arrow pointing upwards, and then you will find above this arrow a list of the mistakes in your code which could not be compiled. So please do this, and then you can check your code whether you have programmed everything correctly. Okay, I wanted to go into detail on the programming of the stiffness matrix and the right-hand side. I will do this now before we go to the compilation. So we have programmed the stress tensor sigma. So what we will now do is we will program the stiffness matrix S in this case, and the right-hand side P. And therefore I will share my the handout with you. Okay, so here on the third page, okay, here we first have the right-hand side. So we first go to the element stiffness matrix. The element stiffness matrix comes in your weak form from this term. So the integral over your body elasticity matrix, or elasticity tensor, material tensor, times epsilon times variation of epsilon dV. We will not go into detail here on how you get to this formula. This you can read from your finite element foundation lecture notes. But this is what we need, this part is what we need to program. So first of all, when we integrate over the body, if we do this numerically, we cannot integrate analytically, so we do Gauss integration. That means we evaluate our operators or functionals here at certain positions and multiply here with dvol. So everything that is being done here is executed at several Gauss points. However, we do not need to take care of that. That is basically being done by the subroutine that you have automatically, more or less. But remember, we are evaluating at the Gauss points. Okay, so then this formula and index notation is the one that you see here. So we have here the elasticity matrixCijkl, the strain tensor epsilon KL, and then the variation of the strains variation epsilon IJ. We discussed before that epsilon can be represented as the symmetric gradient of the displacements, and writing that in a discretized form leads to this term for epsilon. So again, you have here the ansatz, the derivatives of the ansatz functions, and you have the degrees of freedom, just as we had this when we were programming the strain tensor itself. And then here we have the same, basically, for the variation of the degrees of freedom. I will go into what this means with a variation later on. Okay, so this is what we need to program, and this whole term is a scalar in the end. However, what we are computing is a matrix. So what you should remember is that this variation So if you reformulate this term here on the top, when we build our stiffness matrix, this variation of E is basically taken out of the bracket. So we are not considering here this term of the variation. So from this second term, only the Ansatzfunctions go into the formula. And that, when we sort out with respect to the specific nodes, leads to the following summation. So then our stiffness matrix, so then basically you can consider the stiffness matrix has the indices ij, and what we multiply isCijkl, and then we have the Ansatzfunctions. So we have the first term with the indices L and K for the derivatives of the Ansatzfunctions and the displacements. And then for I and J, those refer to the indices here of the Ansatzfunctions in the second bracket term. So when you evaluate this, what you receive is these formulas. I will make this a little larger. So basically, this code is a reformulation of the formula that we had seen before. So this is what you would need. This is this is showing the lines that you would need to program. Our stiffness matrix has the dimension of the degrees of freedom of the total problem. So actually we have 2 degrees of freedom for every node, and we have 4 nodes, so the size of our matrix will be 8 by 8. Okay, there's different ways to derive the stiffness matrix. This is one way. So what you would need to program is then this part. Maybe you have derived it in a different way in the FEM foundation class. Then you can also program it in that way. So sometimes B matrices are used, but here we are doing this without the B matrices. So I will go to the Ubuntu desktop, and that means in your code, this should now look like like the version of the code that you see here for the stiffness matrix. As I said, I mean, the stiffness matrix is in this way, it's quite complicated. It's, I think, the most complicated part of every finite element to program. However, you need it, so you simply have to. I think in this case, you if you have understood the derivation, you simply have to copy the lines for this problem. For the right-hand side vector, I will share again the handout. For the right-hand side vector, we have here the formulation, again, as in the case of the stiffness matrix, given for the we have the formulation here given for the right-hand side vector based on the integration over the body B. Again, we are using Gauss integration. and replace thereby the integral. And we have here sigma times the discretized form of the variation of the strains here. And again, if you go through this, then for your element right-hand side vector, this leads to these two terms that you are programming. So pi, so you have two here because we have 2 degrees of freedom. So one is related to the x direction and one is related to the y direction. So this would then also be done. This would also be done for all the nodes. So here, these are the formulas that you need to program for your right-hand side vector. I don't want to go into too much detail on this here because you should know this from your previous studies of finite element method foundation and also from your nonlinear FEM class. So I will not go into detail on this any further now, but if you have questions, then we can discuss those. So if you have questions, please let me know.
Hello, ma'am.
Yes.
Yeah, where is it? Just a second. Hello, ma'am. Am I audible?
Yes, I can hear you.
Yeah. I have compiled the code and it's running. I'm not having any errors currently.
Okay.
And also it's converging. The error is less than the tolerance which is set. After I think after 2 iterations, it's going below the tolerance.
Okay, which input file are you using?
Cook 8.
Okay, Cook 8 is using a it's using a FEEP. It's using if you go through the exercise sheet 2, Cook 8 is using an input file from FEEP. Sorry, it's using an element provided by FEEP, so it's not using your element 03. To use element 03, you would need to finish the input file, but I can also, to test your element 03, I will create very quickly an input file so that you can test your element 03 without finishing the input files first. Okay, give me 5 minutes and I will upload that in Moodle and then you can check your element.
Yeah, okay. One more thing, hello.
Yes?
I've always had this doubt with the D volume. Okay. If you, in the previous identity vector.
Yes.
Like the handout which you have shared, not the program.
Okay, I can share that.
The D volume, like I have always had difficulty understanding from where this determinant of J comes, the Jacobian determinant.
That determinant that comes basically from the Gauss integration. So from the mapping with the Gauss weights. So you see here that you have the W, which is the weights, and you have that J. So basically, this is, I mean, you have. You're doing everything for for a reference element, okay, which has a, I think for the quadrilateral that you are doing right now, your nodes in this referential space, they have the coordinates -1, -1, +1, -1, +1, +1, and -1, +1.
Okay.
When you have your finite element mesh, so that element has a certain volume. When you have your finite element mesh, your nodes can your elements do not necessarily, or they will not have the same size as your reference element. So your reference element, let's say, has the volume 4. And for that, you can do the Gauss integration and so on. But maybe in the finite element mesh that you generated for one specific element, your element has the volume 8. And that is considered by the det J. You basically go from the volume of your reference element to the volume of your actual element, because J, remember, it's computed based on the shape functions, and those tell you how much your element going from the reference to the natural. From the natural to the physical coordinates, how much it is stretched, basically.
Yeah. Okay. So it's like some weighting factor, like we multiply it to get the actual integral, right?
I wouldn't call it a weighting factor. W, I would call a weighting factor. Det J is more of a mapping of the volume, because if you take out the det J, then I think in that case, all of your elements will just be considered to have the volume 1. But this is not true, or the volume of your reference element. But this is not true. So the det J is related to the mapping of the volume of your element from your reference element to your finite element mesh. So if you call it a mapping, I would be okay. If you call it a weighting factor, I don't know. I think this is not a very precise naming.
Okay. No, I understand. Thanks.
Okay.
Yeah. Hello.
Yeah. Okay. Yeah. You wrote that you have that you are having an error in your when you compile, right?
Yeah.
Okay, so for everyone, I will upload a test input file with which you can run your element 03 without finishing the second part of the exercise, okay? So I will take 5 minutes maximum now to create this input file. I will upload it for you. It's just one element, nothing fancy, nothing complicated. And then everyone who's finished can test with that element. And in just a few minutes, Rajesh, I will be back here and help you with your with the error that you are having, okay?
Okay.
Okay, so give me just a few minutes and I will be right back. right. You should now find an input file in the Moodle course under tutorial videos and additional material. So it is named input file to test element 03.f. This is a very simple input file. It's just 2 by 2 elements and a displacement boundary condition. So with that, you can test your element 03, whether it runs correctly. Okay, Rajesh, you have an error. I will put you again into a breakout room, and then we can have a look at your error. If anyone else is having trouble, then you can write your name in the chat, and then we will discuss that later on.
ma'am. Hello, ma'am.
Okay. The question for the poll is, can you have you finished your programming, and can you compile your program without any errors? Okay, if you can, so not everyone answered, but for those of you who have answered already, can you, I will do a new poll, can you run the input file that I uploaded, the one named block, can you run that without any errors? So does your program compile? That's the question. Sorry, not does your program compile, but do you get convergence in one step? Maybe to show you what I mean with that, I will switch to. I will share my Ubuntu desktop with you. So here you see the input file that I generated for you. It's just a very simple example, a block 2x2 elements, and I'm basically putting a displacement in X direction at one side, and on the other side I'm holding it fixed. And here I'm saying I want to use my user element 03. So in this folder where I have saved this input file, I'm opening a new terminal and I type pv. And now I have run this before. This is why I don't need to re-enter the name. Maybe you need to enter the name block and then run this. And what should happen now is when you type tan, 1 once, you see here the residual norm. This is not equal to 0, but it should go to 0 when you type in tan, 1 the second time. So when you solve your system of equation 2 times, then your residual norm should go to 0 or 10 to the power of minus 12, 13, 14, something like that. So question, who is able to do this in 2 tongue steps? Okay, for those of you who get this within 2 tongue steps, great, then you have programmed correctly, and then you can go to the second exercise, which is simply on the creation of an input file and a small convergency study. For those of you, you're getting, okay, Marcus, you're saying you're getting none. Okay, for those of you who are not getting the right answer, most likely you have made an error in your stiffness matrix or in the right-hand side. It's most likely that it's the stiffness matrix, because like going from one solution step to the next one. I mean, if you get none in your Marcus, for example, if you get none already here, then it could also be your right-hand side. But if you just get it after this step, then most likely it's your stiffness matrix, meaning that you are dividing by 0 somewhere. You should go back to your element 03 and check the programming lines for your stiffness matrix, whether you have made any mistake there. Maybe an indice is not set correctly or used correctly, or maybe somewhere you have made a typo or something like that. Please do that. If you cannot find anything there, then please let me know and we can have a look together. So for those of you who managed to run this correctly with convergence in one step, as we see it here, you can go to the second exercise and work on the input file. For the rest of you, you would need to finish your element 03 first and look for the error there. And please start with your stiffness matrix. Yes?
Can you also do in the second experiment? We have to
You have to write an input file, exactly. So you have one input file. So you should compare with the. Basically, what I want you to do is I want you to practice to write input files in Phoebe. I want you to understand how this input file is written, and the exercise covers a convergency study, which you should carry out with the element that you just programmed, and with an element that is provided by Phoebe, which has quadratic ansatz functions. The one that we did has linear ansatz functions. The one from Phoebe has quadratic ansatz functions. So if you follow exercise sheet 2, then you do this convergency study for both elements. But you first need to complete the input file for element 03. But with the data from, so here you find you see the element. Can you mute yourself? Otherwise we have an echo. Okay. Here you see the element. The input file for the 8-noded quadrilateral element, so the one provided by Phoebe. What you need to change basically is this number up here. You can actually what you can do is you can take the block input file and you can replace this top part by what I have given you in the top of the block command. Also, this number here needs to be set to 0 because you're using a different element type. And then you can replace this block by this block from your block input file, basically. What I want you to do is work with the input file and get a hang of what the individual parts mean, okay? You should also, one thing that you should do also is watch the video of Simon Michael, who is explaining this, because I cannot go into detail on how to do an input file every time in every exercise. So this is why I would like you to work with it today and write your own input file. This is basically what you should do in that exercise. Is it clear what to do, Miklesh?
Yes, ma'am. I will try and I will get back to you.
Okay, great. for everyone, I will upload the final or the completed element files and also the completed input files for you in Moodle, so that you can check your results. So today's exercise will not go into the evaluation for the additional points for the exam. So I will upload everything after this lecture so that you can compare directly. Since we are already over time, I mean, I know that we were last time as well, and I think this online exercise just takes more time. I will be here in this room for another 20 minutes. So if you, for those of you who still have questions, either related to errors in element 03 or the input files or whatever, within the next 20 minutes, we can clarify that. Otherwise, we should take the questions to the next week to the consultation hour. So if you have questions, as always, write in the public chat, and then we can discuss. So I put the section of the code for the stiffness matrix and for the right-hand side to my shared screen so that you can compare with your code and check for the errors that you might have.
Hello, ma'am.
Yes. Yes, I can hear you.
For the right-hand side, for the save function, why are we taking like AI, like I took I comma A, like for the save function for the right-hand side matrix?
Okay, give me a second to have a look at this. Okay, I is the index for the node. So since you need to do the summation over all nodes I, you see this in my code in line 244. There you have the loop running over all nodes in the element. This means you go over all the shape functions that there are, and the nodes are in the columns of the shape shape function matrix. So you have taken IA.
Yeah.
Okay, then this, I mean, it depends, of course, on the way that you set your, if you named your loop counters differently, then this might be correct in your case. If you want to, you can...
Actually, there was a loop counter already. We just need to put these things.
Okay. If this had been prepared already, then you need to change them because the nodes are stored in the columns of the shape function matrix.
Okay, maybe that's the which I was not getting the convergence. Okay, thank you, ma'am.
You're welcome. Does it work now?
No, it's again the convergence is rising.
Okay, can you, I will make you the presenter, and I will have you share your screen here, okay? Because it's time consuming to go back and forth into the breakout room. So maybe you can share your screen here. Can you go to the right-hand side? Please go to the right-hand side code. Okay, that looks good. Can you go to your stiffness matrix? Debugging is somewhat nasty in Phoebe, so you have also mixed up the variables, so if you look, for example, in line 212, you have their shape IA, and I think it should be this. It's the same error that you have in the right-hand side. So you should need to be exchanging the indices here as well.
Okay.
Try that. Try that and check whether it works, and please let me know whether it works, okay?
Yeah, okay.
I think you can stop, yeah, okay.
Yeah. Okay. And can you share the screen, like the solution which you are sharing?
Yes, sure, 1 second.
Hello,
You should now see the screen.
Hello, ma'am.
Yes?
Yeah, I have done the convergence study.
Okay.
So after around 16 elements, after around 16 elements, they both seem to match, man. They get the same values after about the 16 nodes. Sorry.
You mean you take 16 elements in every direction?
Just a second. I'm confirming it once again.
So you have n equal to 16.
Yeah.
Okay. Yes, I mean then this is the result of your convergency study. So it would mean that maybe your element with quadratic ansatz functions gives you the result earlier than the one with linear ansatz functions. So this is there you see, I think, very nicely the difference between the different ansatz functions that are used. So one is more exact than the other one, you can say.
No, that's what I wanted to mention. Like after around 16 or 32 elements, both of them are exactly same. The quadratic and this one.
Yes, exactly. So,
okay.
But I mean, can you mute yourself because of the echo?
Sorry.
Okay, so if you do your convergency study, you should first of all see that they are the same at some point, so they reach the same value, but most likely the quadratic element reaches this value already with a lower number of elements. So maybe you need 16. So 16 times 16 elements with the linear element, with element 03, but you can reach it with the quadratic ansatz functions already with, I don't know, let me say 8 by 8 elements. that would be the interesting point. So that means you need less finite elements when you use the quadratic ansatz functions to get the same physical response, meaning let it be the displacement or whatever you consider in your convergency study. Do you see this?
Yeah. Actually, what I wanted to tell is when we start from one element to element, they are both different. But when n is equal to 16, both of them get the equal values. At the same number of elements, they are getting equal values. Maybe I can share the results. Maybe.
Yes, but does the quadratic element reach this result earlier?
No, it's not like that. For example, for the quadratic element, when n is equal to 16, the displacement in x direction is minus 1.2506, but for our element, it is minus 1.2507.
Okay, so I can share the results after the exercise with you, so that you can compare. So you should see that the quadratic element is converging faster to the value, to the final value, than the linear element. But I have to. I don't have this prepared already. I need to because I slightly changed the exercise setup. So therefore, I need to prepare this in a nice format, but I will upload it after the exercise.
Okay. I will compare it.
Okay. Okay, at this point already, I would like to ask you whether you have any further questions that you would like to discuss now.
وين الشاحن هو؟ يا حبيبتي بس ما هو بده يطفي يكمل. خلوا تكمل تسجيل المحاضرة قبل ما يجي. قشرت تكشير؟
Okay, I see that no further questions are coming. So I will upload the final results to the Moodle course after the exercise, so you can compare your results. Please really have a close look at what we did today, because this was really to freshen up your knowledge in Phoebe. Where do I have to save which files? How do I execute Phoebe? How do I compile with Phoebe? Because especially in this online course format, it takes a lot of time to clarify these questions every time again. So if you haven't done that yet, have a look at the videos, have a look at the material provided. And also, I would be very happy if you take a few minutes and answer the feedback form. And then if any questions related to the course, to this exercise or lecture or anything come up, then you are welcome to come to the consultation hour next Wednesday, and then we can discuss any questions in detail in that time. Okay. Yes?
One last question.
Mm-hmm.
Yeah, in the input file, ma'am, for the Phoebe, the cook 8, there are eight nodes for every element, but we have only defined the coordinates for the 4 nodes. So the midpoints are defined automatically. Am I right, ma'am?
Yes, the midpoints are determined automatically.
Okay, so suppose if I have to use if I want to use a cubic interpolation function, then again, like if I can just changing this 8 to 6, the appropriate value would suffice, or I have to write the input file again from scratch?
Well, what you would have to change, maybe I can show you in the input file. Could you mute yourself?
Sorry, just.
Okay, thank you. So actually, what you would need to change is, first of all, this number here, because then you would have more nodes in your element. What you would need to change also in this part, in this block command, is this entry here, this 8. This 8, actually, I will share a file with you, which is the feed manual. So the block command is a command which you can use to easily set up some simple boundary value problems, which we did here in this example. So if here for this last number in this block command was 8, for the cook 8, and this is referring to this line here for 8 noded quadrilaterals, okay? So if you had if you have, for example, the 4 noded quadrilaterals, what you would need to do is set it to 0. This is referring to this entry here. If you have cubic elements, I don't know if that is covered by the block command. I would need to check, because cubic Ansatzfunktions are, I mean, they can be done, but they are not so typically used in the finite element programs. For example, I think if you go to Abacus or ANSYS, cubic Ansatzfunktions are not the common implementation. Usually linear Ansatzfunktions and sometimes quadratic Ansatzfunktions are used. But if this is provided here, then you could use this command as well, and then the nodes in between would be generated by FEEP itself.
Thank you, ma'am.
You're welcome. I will upload the manuals for you for FEEP as well in the Moodle course. So then if you sit at home and you happen to have a question and you want to look something up, then you can refer to that as well. They are quite dense, but maybe they help in some way. Okay, so I assume, since nobody else raised his or her hand, that was the last question for today's exercise. So before closing, I would like to thank you for your participation and your attendance. It's nice that also in this online format, it's possible to interact with you in this exercise, and then I'm looking forward to seeing you in the next week. In the next week, there will be an exercise on nonlinear elastic material laws. So we will do another exercise next week, and the topic is based on the lecture that you worked on in the last week. All right, so I hope you have a good rest of the day and a good rest of the week, and then we'll see each other next week. Bye-bye.
You are currently the only person in this conference.
خذني اياها المطبخ يابا بس مسح المطبخ. لا مش هضرب بدناش هضرب مسح الارضيه. هاي الدلو عندك وطها وعصرها وامسح مسح بس يا حبيبي. لا بس اخبار لا شطف بدناش نشطف هسه بس امسح من الغلبه وفرش. لا تحكي المطبخ يابا. ما هو يابا اخبطها مشان بدنا نشطف جوا. والله ناسي وقت بدها تفوت وقت بدها تفوت. يلا عادي ما في مشكلة. لا انا موسى. هلا كيفك ابوي اخبارك؟ كيف صحتك؟ كيف الاتيكيت؟
لا
احسن خلاص. خلص هسه بالبراد ان شاء الله.
لو الشباك نزلوه تردوا صح؟
لا يابا يمكن تحفظ.
لا مو عشان شوف اللي يحطوا هذه لا شغلتين ديكور اللي يحطوا.
بتحط ديكور؟
بيحطوا هيك. ويابا مش منظر والله
خلص
كسار
مش
مطعوج.
مفهوم. اذا مش مطاوج هو
بده ايش ان كان.
هاي البلوكة معمر من زي هذا بس هاي زاوية البلوكة انت ما كبيت البيت. عرفت مش مطاوج.
لا الكسار مطعوج ظل مطبات مش منظر. قصده السلك. وقصده السلك ما لا اي سلك السقف. انا قصدي عن السقف بقول الكسارة طلت شيف مطعوجة.
مطاوج والله. شفت هاي الوش؟ ولا هاي قديمة. كيف مليح
بقول انجليزي.
لا خلصوا هذا بس بقية يعني انتو حمام بقى كان حمام لواحد لان لو جيت بكره ما ظنيش يجي السبت ما رجعش لكم.
بس هاي ماشي شوف تروح تحكي الباب قبل ما تغسل غير الباب. نغسل هون بعد نفوت يعني شوي زين. سقف خلاص على شو يا رجل؟
هاي غالي يا نفوله. بس مسح يا
والله سامحك طبيعي. ايوه وين هو؟ طب هي صبيعة بكيت لا حرام.
شو عادي؟ طب انت بدكيش تشرب محمد.
طب والله انا ما عملتش بك عشان كده. ابوي
تشرب خليه لازم تشرب.
يا حبيبي
ولا تنزل تشرب من فترة لا تاخذ
انا والله ما جبتش حرام عليك.
لازم تدفع هلا. خبرت لازم تدفع. لازم تدفع.
хорошо شرب بعضكم شرب بعضكم.
يلا يا ناس ثواني بالله. أنس ثواني يا ناس.
The only person in this conference.
والله بحمل هالتلفون. أنس بس خلينا نجهز الأكياس. هاي كيسان بدي أشيله من الثلاجة وهذا الجاي.
يلا نجهز أكياس.
إذا بس أعطوني من الثلاجة.
والله طلع حجار هيك وطلع كل درهم 24.
انا كيف بدك انت قلت يا ولد تسوي زبط يصير يعني نظام مره هيك.
يا بالعكس منظر تخلي. اي
الموضوع منه طبعا.
هذا برا بدي اسويه اوكسيديرس سفينه. الناس قاعد بتركبه والدجاج ببلاش بتشتغل شوي. يابا والله لك صار مطبات والله مو منظر يدهن ظلك كل سنه يدهن. احطه خلص بروح مع الحمام زي الباب. ماشي بدون قلوبات وخلص القلوبات حطك واحده فوق المركب. لا بتجيب صنبار.
يلا جاهز. الفال هاي شاحن.
الفرن الصحن
أخذتها.
حطيته على الشاحن.
على الشاحن في 51. والله صح.
اسمه التكمله كمان.
51 انفال. يلا جاهزا يلا. يا بدك شيء؟ بدكم شيء؟ السلام عليكم. لا بعده والله. ما هو بعده ما هو تاهم يسكرون ما اقدرش اسكر. ها؟
حولته يعني.
شو حولته؟
شو بتقول حول؟
حول على النت اللي عنده وضل مسجل.
خلص.
ما هو بتاعي يسكروا من عندهم هم. انت وين بدك تروح؟
نوديك
بس؟
روح معاذ ليش؟
تروح معاذ؟ مين معاذ؟ معاذ شو اسمه؟ طيب بس بدي اشتري بكره الدنيا حظر، بس بدي اشتري باكيت دخان وبس اصل الدار بنطيك وانت رايح معاذ تشتري وتجيب لي اياه. كيف؟ هسه بدي اشتري باكيت دخان بس اصل الدار بنطيك غاد معي مصاري، بنطيك 2 وربع بتجيب وانت مروح بتجيب لي واحد، او اذا معك 2 وربع هون هسه بس بعطيك اياه.
معلم عجي هاي طلعت والله. هنا سوينا تبي فوق. يلا يجي. يلا سلام عليكم.
الساعة 7. بكرة الدنيا حظر. معك ولا خلص معك ربع هون؟ فيش؟
تعال
غيره.
جاي لباب الدار اليوم.
شفتها إذا فكرت جاي عبويني قلت أبوك شكلها عارفة، بس لما فات شاي ضارب وجيه قلت معناته خلص شو يسمى 5 ساعات دخيل والله.
وين راح كانت؟
هذا الإخوة فخشاد راضي هذا فرحان كبير.
أيوة
هي كانت شو
راحوا دار متهب، فاتوا دار متهب
جهديد فاتوا.